Okay, so basically today we are on the experiment number 4. So the experiment number 4 is about the waves and oscillations. Okay. Um, so the learning outcome for this lab will be, first you're going to explore a few simple characteristics of wave, such as frequency, wavelength, wave speed, and wave amplitude. Okay, and then next we're going to analyze the relationship between the frequency, wavelength, and the speed of the wave. Okay, and also we're going to look into some of the factors that affect the frequency and the period of the vibrating mass on the spring. Okay, and then also we're going to look the relationship between length of the spring and the mass system, which is related with the oscillation frequency. And then also we look into the energy that involved, which is the mechanical energy. And then lastly, the factors, right, that determine the amount of gravitational potential energy. Okay, elastic potential energy, kinetic energy, and thermal energy in the spring mass system. Okay, so basically, in this lab, we're going to look into the experiment of pendulum or spring. Okay, so for example, we have a periodic motion object such as a spring, okay, pendulum, or bobblehead doll. Okay, so where it will go back and forth, all right, about a fixed position in a regular and repeating fashion. And then the periodic motion is regular and it can be repeated. Okay, so meaning that, so let's say the spring is oscillated to one side and then go back to another side, so we can consider that as one period. Okay, because from original position goes to the maximum position and goes back to the original position, so that's one period. So one period is one whole cycle. Okay, and then from there we can describe the frequency. Okay, and then the frequency is defined as the number of complete cycles occurring per period of time. Okay, let's say for once you are quantifying the frequency, let's say how many complete cycles that can be made within a second, right? So let's say you have 3 cycles per second, then your frequency will be 3 cycles per second. Okay. Okay, and then the cycle per second, the unit can be converted to the hertz, right? So that actually you have learned before. Alright, so this is just example. So we have 256 hertz tuning fork. Okay, so it goes back and forth for 256 cycles. So within a minute, within a second. So that is the frequency of that tuning fork. Okay, meaning that for one cycle, right? For one cycle, so you divide by, okay? So 1 over 256, so you obtain 0.00391 second, okay, to complete one cycle. So you can use this relationship, okay, to define the frequency. Okay, next we also have another wave parameter, which is the wave speed. Okay, which this one is associated with the movement of crests and troughs along the medium. Okay, where it means that the faster wave will have crest that move from the left side, okay, left side of the screen to the right side of the screen in less time. Okay, that is the crest move from left to the right faster. Okay, so the wavelength, so the length of the wave. So wavelength is the length of the wave. So how long is the wave? So that can be referred to by repeating pattern of crest and troughs. So meaning that we have that pattern, okay, that crest and troughs. So if it is having the wavelength is having also relationship with the frequency. Okay, so the short wavelength, okay, have crests that are relatively close to each other. So meaning that that is a short wavelength. Okay, so we have so many waves going to minimum and maximum. So we have that wave as having the short wavelength. Right? Then if that one, that wave, so it is not too cramped. Okay, so it has a longer wavelength. Okay. All right. So we're going to start with our first experiment. So let's say we're going to open up the first simple wave simulator over here. Okay, you can go to the link. Okay, over here. So I open it. Okay, so you look at the simulator here, right? So we can toggle, all right, the frequency, okay, the wave speed, the wave speed, and the wave amplitude. Okay, so you can toggle between that. Okay, first we're going to set the animation, okay, to show waves on a rope. Okay, so this is a rope. Okay, so you can change that, okay, over here. So one as a sound and one as a rope. Okay, so we take this one as a rope, and we're going to use the real time. Okay, so this is already in the real time. You can pause, slow motion, and make it in the real time. So the real time meaning that it runs at our original pace of time. Okay, so you see that it's 12, 13, 14, right? If it's slower, then it will be slow. So the seconds moving a little bit slow. And fast, of course, it will move much faster. So we use the real time. Okay, so you need to set all of these values. Okay, so you use this slider to change that. Okay, then you need to answer some of the questions over here, right? So it is regarding the rope, okay? Whether you move along a line from left to right, okay? So you need to answer all of this by yourself. Okay, so some of these questions will be part of your lab report. Okay, so experiment number 1 is a little bit simple. So it's just based on your observation when you change the values within the simulator over here. Okay, give me a few seconds. Okay, hold on. Okay, now we're going to look into the second experiment. Now we're going to look into the vibrating mass on a spring. Okay, so we have a second simulator. So you go to the link. It is also from the physicsclassroom.com as well. So okay, so basically, so for this spring, so you have two springs over here. So you can compare with each other, and also you can actually put, right, some of the weights, right, into this spring, okay, and you can change their damping, okay, dampness, and also the stiffness. Okay, so this is for spring number 1, and the brown one is for spring number 2. Okay. If you want to detach that, you can just try to grab that and then remove it. Okay. And then it actually is quite fun, right, over here. So you can rearrange all of the blocks, okay, by dragging it. Okay. Okay, and you can also reset back if you want to have the original setting. Okay. All right, so first of all, we're going to place a mass, okay, over the mass. And then you're going to observe the vibration, okay, vibration, and click the start button. Okay, you go over there. Let's say you reset that. And you start, and then put a mass there. So you can see that, okay, if it is quite stiff, then it won't move further, all right? But if you change the stiffness, for example, but over here you set back, you make it less stiff, right? And you start it, so you can see that how it behaves, right? It will give you more amplitude, right? And then let's say, okay, so we are at the number 4. We're going to place a mesh, okay, on each of that. Okay. So let's say this is at the original position. Start first. Okay. So there will be 2 graphs plot on each other. All right. So basically you can do the comparison. So with a better weight, actually you will see more oscillation from the spring. Okay. Okay, and then you look over here that you can move this slider, okay, to see the changes that happen before, right? Okay, and then over here you will see the value of the recorded height and velocity. Okay. And then, right, so you need to answer what are the factors that affect the frequency and the period of a vibrating mass on a spring. Okay. And then the mass and the of the spring can be easily tested as possible factors. If you are quick, you might also be able to test damping as a possible factor. Okay, so you might change the damping as well to see, okay, how it affects, okay, the velocity and the height of the spring. Okay, so you need to conduct several trials. Okay, so this is should be in the lab report, where you need to measure the period by recording the difference in time from the start and the end of one cycle or of several cycles. Okay, so you list out, okay, let's say in this table, all right? So you need to record start time and stop time, and you record the period, and then you will mention the frequency. Okay, so list out. So it might be on the different factors. So maybe first, factor 1 is maybe the stiffness of the spring, and next a damping of the spring, and then maybe the mass, okay, mass of the object. Okay, so you need to analyze that results and do some discussion. Okay, so that's about experiment number 2. All right. We have also experiment membership. Actually, we're gonna have up to 6. If I'm not mistaken, up to 6. Sorry, up to 4 experiments. So we have discussed 2 experiments. Okay, now we are on the experiment number 3. Okay, now you're going to open a different simulator, which is on the ophysics, okay, ophysics.com. So you open this. Okay. All right. Okay, now we are on the simple harmonic motion experiment. Okay, what you need to do over here, okay, you look at the instruction. So first you need to run. Okay, click the run button. So there is a run button over here. Okay, so you see the block, okay, moves back and forth, okay, by the attached spring. Okay, so you see the change of energy on the graph. Okay, so over here there's a change of energy. So this is mechanical energy. Okay, and you have the position over here. Okay, so you see the changes of that. Okay, so he asks you a question. What is the value for the maximum kinetic energy? Okay, when it is maximum. Okay, so you need to note that. Click on the pause button at the right position to take the reading of the maximum kinetic energy. All right, so you look at the maximum kinetic energy when it happens. Okay, it is over there. All right, somewhere between that. Then you push back. It's somewhere over there as well. So you look at it is when it is at the position of x equals to 0. Or you can also use this button as well. Run and pause. Okay. So it's too quick. Okay, so you can adjust the animation speed as well. But seems like this. So you can yeah, over here, right? You want to change it, make it slower, right, or faster. Okay, so you can control that. Okay, so it is much easier for you to get the maximum value. Okay. All right, so we ask you a question again. What is the value for the maximum elastic potential energy? So you need to answer this. Okay, state any changes observed in the parameters. Okay. In number 5 and 6, you need to answer the question. Okay, number 7 also you need to make conclusion based on your observation. Okay, so that's about, all right, experiment number 3. Okay, and then we have the last experiment. Okay, we have the last experiment. So over here, we go to the PHY simulation. Okay, so for the PHY simulation, okay, you go to the link, right? Okay, energy, all right, energy simulator, and then drag the mass and attach it to the spring. Okay, you have the mass over here, and then drag it to the spring, attach that. Okay, and then you see the spring moves back and forth. Okay, so you need to observe the difference between, so you have already the mass attached on the spring experiment before. Okay, you need to compare with this, okay, and explain the difference. Okay, and then you need to set the damping effect. Okay, damping effect to known, right? So over here, you put a damping effect to known and observe what happened to all types of energy, okay, when the initial X displacement is increased. Okay. All right, and then state the relationship. Okay. So you can use this ruler actually, okay, to estimate the initial X position. Right. So you can observe that. Okay, and actually you can estimate how long is the spring. Okay. Okay, so you need to answer that. Right. So you, and also you have the stopwatch as well. So this is for the recording purpose. Okay, and then you might, on the number 6, you might need to increase, okay, the damping effect, okay, to see how it affects the spring. Okay, you can see that. And you can also actually change the mass of the spring over here if you wish. Okay. So for running the stopwatch, you need to drag it, okay, and then only you can run it. Okay. All right. So lastly, you need to make the conclusion, okay, based on this experiment. So after that experiment, so you need to compare all of experiments that I mentioned from experiment number 1 up to experiment number 4. You need to answer out of these questions. Okay. Right, so I leave all of these questions to you. All right, so just answer that. Right, once it is finished, so you make it as your lab report. Okay, so that's it about our lab session today. Any other question? If you are unclear about something, right, just let me know. Okay, so prepare your lab report. Okay, for the last 3 weeks lab report will be due, as I mentioned yesterday, will be due on Friday. Okay, I need to check that on the Putra Blast whether I have put the assignments box for you or not. Okay, and then you can submit it there. And then for you, as usual, on Monday, okay, in the next 2 weeks. Okay. Okay, so that's it for our lab session today. Right, so we will continue with the lecture on Thursday. Okay, maybe we need to speed up some of the topics, right? And we will look into that. Maybe I'm going to just give you the lecture notes later, and then we're going to do more problem solving. Okay, so I hope you can probably do what we call that, do the reading on the lecture notes, and during the class session we might go into the problem solving techniques. Okay, if there is no further questions, okay, so let's turn on your camera. So we're going to record the attendance for today. Okay, come on everyone. So we got 5 students are missing today. Maybe they are still in the Hari Raya celebrating mode. Okay, come on everyone. Turn on your camera. I'm going to start counting now. All right, so 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, give me one more shot. Okay, thank you. All right, so enjoy the rest of the day. Okay, so I see you again on next Thursday. Okay, Assalamualaikum and bye-bye.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Thank you, Doctor.
Doctor.